Right guys, we're going to have a look at the reactivity of group 7 metals, also known as halogens, okay? Halogens, when they form their ions, they're called halides, okay? So for example, chlorine, okay? When chlorine forms an ion of Cl minus, we call it chloride. When fluorine forms an ion of F minus, that is fluoride, okay? Always ends in "ide" when it forms an ion. Right, so let's just have a look at the reactivity. So just like I would suggest watching the video on group 1 metals, okay, because the explanation is the opposite for group 7 elements, okay. So if we have a look at group 7, they're known as halogens. So in order for group 7s to actually react, they need to gain an electron, okay, because group 7, they have 7 electrons in their outer shell, okay? So the group number tells you the number of electrons in their outer shell. In order to become stable, it needs to gain an electron. It needs to have 8 electrons in total. Right, so it needs to gain an electron. So when it gains an electron, so it becomes a 1 minus ion, okay? Like Cl minus, Fl minus, Br minus, etc. Okay? It has to form the ion first before it can react. So we need to think about the ease of a halogen gaining an electron. So what we need to think about is how easy it is for a halogen to gain an electron and the factors that would affect the ease of a halogen gaining an electron, okay? So there's a couple of factors that we need to consider, but let's actually talk about the atomic radii and the ionic radii, okay? So if we go down the groups, fluorine is a very small atom, okay? So I'm not going to show you the actual number of shells, but I'm just going to visually show you what's happening in terms of number of shells, etc. So fluorine is a very small atom, but if we go down to chlorine, okay, it gets a little bit bigger. Bromine will be even bigger. Iodine gets even bigger, okay? So you get the point. So as we go down the group, the atomic radii increases. It's the same for pretty much all the groups on the periodic table. As we go down, because the number of electrons are increasing, the atomic radii increases as well. So for example, if we look at the halogens, we're going from, if you look at your periodic table, for fluorine we have 9 electrons, chlorine 17, bromine 35, okay, so there's a big jump in electrons. So if we're adding more electrons as we're going down, the number of shells will increase. And like I said in the previous video, examiners love the word shielding, okay? So shielding just means the number of shells. So as we go down, the shielding increases. Okay. We also need to talk about nuclear charge. So nuclear charge is the ability of an atom to pull in electrons, or more of the ability of the positively charged nucleus to pull in the outer shell electrons, okay? Because it's actually the nucleus that's pulling in the electrons. So in the nucleus we have protons and neutrons, okay? The protons are positively charged. The electrons in the shells are negatively charged, so it will pull in the electrons, okay? So that's essentially what nuclear charge is. So as we go down the group, the nuclear charge decreases. Okay, so those are two things that are happening. We do need to also mention electrostatic attraction. So electrostatic attraction is the attraction between a particle that is positively charged and a particle that's negatively charged. So when we're looking at the atomic structure, the positively charged part is the nucleus, okay, and the negatively charged part will be the outer shell electron, or any electron that it's trying to gain, okay, because like I said before, group 7 elements are trying to gain an electron, okay, so it needs to essentially attract this electron. So as we go down, what happens is the nuclear charge decreases, so there's less of a pull for any outer shell or electrons, or any electrons that it's trying to attract. The shielding also increases, which affects the electrostatic attraction, okay? So again, you can write down that electrostatic attraction decreases as you go down the group, okay? these are for anything, these points that I've mentioned are for going down the group, okay? So those are the things that happen, right? So what that means is if the electrostatic attraction is decreasing, that's because the distance between the positively charged nuclei and the outer shell electrons will decrease, or any electrons that it's trying to gain, okay? So if you look at the arrow, the size of the arrow is increasing, which means the electrostatic attraction is becoming weaker, okay? If it's becoming weaker, what happens is it will become very difficult to gain an electron, okay? So it will require a lot of energy to gain an electron, okay, as you go down. Right, so as you go down group 7, the reactivity decreases. The reason for that is because group 7 halogens are trying to gain an electron. So if it becomes more difficult to gain an electron to form that 1- ion, reactivity will decrease as you go down group 7, okay? So in group 7, fluorine will have the highest reactivity, okay? That's because it's a very small atom. Any electron that it's trying to attract will be very close to the positively charged nuclei. Same with chlorine, okay? And because of that, it will be able to attract an electron very easily.